Hey everyone, and welcome back to Talk Tensors. We've got a really fascinating paper to dive into today. It's making some pretty big waves, in the medical imaging world.
Yeah.
So, imagine if we could get way more information from a standard chest CT scan, but without upping the radiation. That's basically what the researchers behind this paper have done. The title's a bit of a mouthful. Beyond the lungs. Extending the field of view in chest CT with latent diffusion models.
Yeah, they've achieved something pretty remarkable here. It's a really clever application of AI, specifically using a type of machine learning model called a latent diffusion model. And, these models are really known for being able to generate these incredibly realistic images. And in this case, they're using that power to basically fill in the gaps in chest CT scans.
Right. Okay, so let's jump into the paper itself. The paper starts by highlighting this problem. Most chest CT scans, they just focus on the lungs. Right? It's like you're only seeing one piece of the puzzle when you really need to see the whole picture. Especially because we know lung diseases can impact other organs too.
Exactly. And there are really good reasons for that limited focus, like the main ones being cost and concerns about radiation exposure. The authors specifically mention the National Lung Screening Trial, which recommends a protocol that only covers the lung region. So that leaves these other important organs like the liver and kidneys only partially visible in the scan.
Yeah. Okay, so how did the researchers actually tackle this? Did they just train the AI on a ton of full body scans?
That's a good question. Not quite. They actually came up with this really clever two-stage training strategy. They call it SCOPE, which stands for Spatial Coverage Optimization with Prior Encoding.
Scope. Okay, I love a good acronym. So tell me more about these two stages.
All right, so the first stage uses what's called a variational autoencoder, or VAE. Think of it like this. It's creating this super detailed blueprint of each 2D slice of the CT scan. So it basically compresses the data, but keeps all the really important features.
Okay, so it's like creating a really efficient summary of each slice.
Exactly. And then these blueprints are stacked to create this 3D context for training the latent diffusion model, or LDM. And this LDM, this is really where the magic happens. It actually learns the spatial relationships between the slices, essentially figuring out the rules of human anatomy.
Oh, wow. So it's like the LDM learns how all the different parts of the body fit together, kind of like those anatomical models you see in doctors' offices.
That's a great analogy. And this is what allows Scope to do something pretty remarkable. It's called zero-shot FOV extension. So what that means is during inference, it can actually generate new slices without needing to be specifically trained on full body scans.
Whoa. Okay, so it's basically using what it's learned about anatomy to predict what those missing parts of the scan would look like.
Precisely. Exactly. It's like you're giving the AI a puzzle with missing pieces. And it's using its knowledge of how bodies are structured to fill in those blanks.
That's amazing. So to test this out, the researchers used a data set of full-body CT scans, but they masked out the lower abdominal regions to basically mimic the limited view of that lung screening trial data, right?
That's right, yeah. And the results were really impressive. They were really impressive. The AR-generated images were visually realistic, and when they used a segmentation tool called Total Segmentator to analyze the liver and kidneys, the volumes matched up really well with the actual scans.
Wow.
They also used some quantitative metrics like SM and PSNR, which essentially measure how closely the generated images match the real ones. And the fidelity was particularly high when the number of missing slices was small.
Okay, this is where it gets really interesting. So they also tried applying scope to actual images from the National Lung Screening Trial. And it successfully extended the field of view to include the liver and kidneys. That's huge.
It really is. Think about the implications for diagnosing and treating lung diseases. We could start to see how these diseases impact other organs much earlier, which could lead to more effective interventions and, ultimately better outcomes for patients.
Right. It makes you realize that we often think of the body in these isolated systems. But this research really highlights how interconnected everything is.
Absolutely. And this approach of using AI to extend the field of view, it could have applications beyond just chest CT scans, right? Imagine using it in other imaging modalities like MRI or even ultrasound. The potential to unlock this hidden information is just huge.
Yeah, that's a great point. Okay, but before we get too carried away, the researchers do acknowledge that there are some challenges to address. One that stood out to me was controlling where scope stops extending the field of view. How do they prevent the AI from just generating slices endlessly?
Yeah, that's a key point. Right now, Scope doesn't have a built-in mechanism for that. But the researchers suggest integrating something called a body part regression model, which could essentially tell the AI where to stop. based on like anatomical landmarks.
Oh, okay. So it's like giving the AI a map of the body to guide its exploration.
Right, exactly. And this speaks to the iterative nature of research. This paper is a fantastic step forward, but there are always more questions to answer and more refinements to be made.
For sure. But I mean, the potential impact of this research is undeniable. It's exciting to see how AI is being used to not just analyze medical images, but to actually enhance them, providing this more comprehensive view of the human body.
Yeah, I completely agree. It's a great example of how AI can really complement human expertise. Radiologists and other healthcare professionals can use this technology to see more, understand more, and ultimately make better decisions for their patients.
Absolutely. So now that we've kind of delved into the paper itself, I'm curious to hear your thoughts on the novel notions segment. Based on this research, what are some potential avenues for future exploration? What's got those gears turning?
Well, one thought that comes to mind immediately is the possibility of incorporating real-time data into this extended field of view. Like imagine combining the anatomical information from the CT scan with physiological data from wearable sensors.
Okay. Yeah, I can see where you're going with this. You'd have this dynamic evolving picture of the body that shows not just how the organs are structured, but also how they're functioning in real time.
Exactly. You could track things like heart rate, blood pressure, even activity levels, and see how they relate to what's happening in that extended field of view, generated by scope. This could be incredibly valuable for understanding how different systems in the body are interacting and responding to various stimuli.
Yeah, it could open up some really interesting possibilities for predictive modeling too. Right. Could we use this combined data to anticipate potential health problems before they even become visible in traditional imaging?
That's a fascinating idea. It definitely aligns with that broader trend of moving towards personalized and preventative medicine. Imagine a future where healthcare is less about reacting to disease and more about proactively maintaining well-being.
Yeah. And speaking of pushing boundaries,
Yeah,
what if we could combine this real-time data with genetic information?
now you're talking. Integrating genomics into this model could provide even deeper insights into an individual's health. We could potentially tailor treatments and preventative measures based on a person's unique genetic makeup and their body's real-time responses.
Yeah, this is definitely venturing into the realm of novel notions. But it's not totally far-fetched, right? We're already seeing the power of personalized medicine. And incorporating AI-powered imaging and real-time data could take it to a whole new level.
It's a really exciting prospect. Of course, there are numerous challenges to overcome, both technical and ethical. Like data privacy and security would be paramount, and we need to carefully consider the potential impact on patient autonomy and decision-making.
Absolutely. Those are really important considerations. But these are conversations we need to be having. As we develop and deploy these powerful technologies, it's about making sure that AI is used responsibly and ethically to benefit everyone.
I couldn't agree more. And, I think this research serves as a powerful reminder of the importance of collaboration between different disciplines. It's really the intersection of computer science, medicine, and engineering that's driving these incredible advancements in healthcare.
Yeah, it really highlights the potential when different fields come together
Yeah,
to solve these big problems.
exactly.
Well, it's been a fantastic discussion.
It has.
And thanks for sharing your insights on this groundbreaking paper. To everyone listening, thanks for joining us on this deep dive into the world of AI and medical imaging. Until next time, keep exploring, keep learning, and keep those novel notions flowing.
Absolutely.